Hey folks, this is Shetz, and I will tell you one thing. If you haven't done 9-1 or watched the video, What is a Radian, you are seriously going to be lost. So please make sure that you watch those videos and that ed puzzle first. Please look at these videos over and over again. Pause them if you have to. So here's a 1 radian, 2, 3, 4, 5, 6. And when we come down here, we know that the circumference of a circle is 2 pi r. And if r is 1, then when we go once around the circle, we will have 2 pi radians, which is 6.28, twice 3.14. We know that one circle is 360 degrees, or 2 pi radians. Therefore, 360 divided by 2 pi is 180 divided by pi radians. 2 goes into 360, 180 times, which turns out to be, if you actually punch this in your calculator, 180 divided by 3.14, you will get 57.3 degrees. That is a number that you need to memorize. So therefore, 1 radian is 57.3 degrees per 1 radian. So 1 radian is 57.3 degrees. Okay, we go over to our next page, and not only do you have to know this counterclockwise, you also need to know this clockwise, negative radians. Well, -1 would be right there. -2 would be right there. Oops, I forgot my negative on the first one. Here's -3 radians about there. -4 radians will be there. And -5 radians would be right there. And -6 radians would be right there. And we know this is -6.28 right here, once around the circle going clockwise. Remember, clockwise are negative angles, and counterclockwise is positive. Here's positive radians, angles, and this is clockwise. All right, folks, nothing else is there. Let's go on to the next page. And we know that if we go once around the circle, all the way around the circle, we've gone 2 pi radians. Well, half of 2 pi is pi. And we also know that pi is 3.14. Twice pi would be 6.28. Now, if we go pi radians, half of that distance will be pi over 2. Oops, let me get rid of that first. There we go. Which pi divided by 2 is 1.57. And this whole page, if I don't have radians after it like I do right here, that should be 1.57 radians, or pi over 2 radians. Okay, now all we're going to do is count. 1 pi over 2, 2 pi over 2, down here will be 3 pi over 2. And then 4 pi over 2, which reduces to 2 pi. Okay, well, if this is pi over 2, half of that distance would bring us right to there. And half of 2 pi over 2, I'm sorry, I said that wrong. Half of pi over 2 is pi over 4. Now, folks, all we're going to do is count. 1 pi over 4, 2 pi over 4, this is going to be 3 pi over 4. 4 pi over 4, this here is 5 pi over 4. This is 6 pi over 4, 7 pi over 4, 8 pi over 4 reduces to 2 pi. So right there, splitting the quadrant exactly in half, splitting pi over 2 in half, gives us a pi over 4. Now, we've just counted by pi over 4s. Now we're going to count by pi over 6s. So if this is pi, watch this. One, two, three, four, five, 6 regions. Therefore, if we divide that up, pi went a little too far back. Okay. So when I take pi and cut it into 6 parts, guess what? I'm counting by pi over 6. So this is 1 pi over 6, 2 pi over 6 reduces to pi over 3, 3 pi over 6, 4 pi over 6, 5 pi over 6, and this is 6 pi over 6. So again, re-watch all this and look at the way I count. I'm just counting. That is it. Well, if this is 6 pi over 6, this is 7 pi over 6, 8 pi over 6 reduces, 9 pi over 6, 10 pi over 6 reduces, 11 pi over 6, and 12 pi over 6. This chapter, you are going to get very good with your fractions, how to reduce and things like that. So the oranges, the orange colors, are pi over 6s. The reds are pi over 4s, and the blues are pi over 2s. Sorry about that. And we do know that you know that pi is the same as 3.14 radians. Well, here's 1.57 radians. And if I count by 1.57 radians, here's another 1.5, and another 1.5 is 4.71 as a decimal. This is exact. This is a decimal. And that's another thing that you're going to have to learn is being exact and as an approximation. These decimals right here in green are all approximations. All the blues and the oranges and the reds, they're the exact answer. Okay, we scroll down here. Sketch the following. Now, this is what I always do. We know that if I would do half the circle here, I've gone pi radians. Well, I always label whatever fraction we have, whatever denominator, the numerator is going to be the same. So all the way around 180 degrees will be 7 pi radians. Half of 7 is 3.5. Well, notice we want pi over 7. Well, that's smaller than a 1/6. So I have to do something pretty small here. And please don't forget to write your angle, showing that we've gone counterclockwise. We go to problem 2 here, and again, I always label this, I always label this here as 5 pi over 5. Whatever this denominator is, the numerator is, once we go 180 degrees. Half of 5 is 2.5, so I know we want a 3, so we have to be just over 2.5. And there you go. And don't forget to draw your counterclockwise arrow. Same thing with problem 3. I could use the same graph, but I'll give you a new one. Here's 5 pi over 5. Half of that would be right there. And if I would add another 2.5 to 5, I get 7.5 pi. Now we only need a 7, so I need to be just before going straight down. So that would be right about like that. And again, don't forget to draw your counterclockwise arrow, just like you did in section 1. Okay, continuing on. Let me just go back 1 second, make sure I didn't, oh, yep, we got everything there. Let's go to this guy. And we're continuing to write these. Now this time this is negative, so now we have to go clockwise. I need a -7. Here's -2.5. Here's -5. Here's -7.5. I need to be just before this. So we can go just like that. And again, draw your arrow clockwise. There you go. We always start in standard position. 4 pi radians, well, you think back to our chart, and we know this is about 1, 2, 3, 4. There you go. Don't forget to draw your arrow. I know this looks like it's strange because there's no pi in it, but that's just 4 radians. 4 radians. Okay, continuing on to a -3.5. Well, we know that going clockwise, this would be -3. We should just be under 4. Go back to the chart if you need help that we did at the beginning of this video. And there you go. So this is quadrant 2. This one's quadrant 3. And this one's quadrant 2. All right, we scroll down here. Coterminal. That just means all we have to do is add and subtract a whole circle. Well, in radians, that's 2 pi. And in twelfths, that would be 24 over 12, which is 2 pi. Again, as I told you, we are going to be very good at reducing fractions and finding common denominators and things like that. So we have to add, coterminal means add and subtract 2 pi. Well, in twelfths, that's 24 pi over 12. And when we get 1 pi over 12 plus 24 over pi over 12, we get 25 pi. 1 plus 24 is 25. Now we also have to do 1 minus 12. Well, 1 minus 12 is, 1 minus 24 is -23 pi. There you go. Now we're in fifths. Well, when we add and subtract 2 pi, 2 pi is the same as 10 pi over 5. -7 plus 10 would be 3 pi over 5. And -7 minus 10 would be -17. There you go. We get into complement and supplement. Well, we know that complement is 90 degrees. And in radians, straight up, it's pi over 2. So I have to get to a 6 pi. This is a half pi right here. So if I'm at 1 pi over 12, I need to get the 6 pi over 12. That means I need 5 more pi over 12. Great. Supplement. That means 180 or pi. Well, in twelfths, that's 12 pi over 12. And if I'm at 1, I need 11 more to get to 12. So there's your answer there. I will continue this with another video.